Hello. Good evening, everyone. Welcome to the live interactive session for the Mapping Toolbox. I'm Vishaka Srinivasan from MATLAB Helper, and I have with me Roshni, who is the host, and Manoj, who will be the co-moderator. Manoj?
Hello everyone, my name is Manoj Sai from MATLAB Helper. I will be the co-moderator for this live interactive session. Along with Vishaka, I will be asking questions to Roshni. So if you have any queries, please post it in the comments.
Hello everyone, I am Roshni from MATLAB Helper. I'll be hosting this live interactive session on the topic of mapping toolbox in MATLAB. Hope you guys have seen my webinar and I'm looking forward to answer your queries.
So before we begin, I'd like to mention that we're giving away free courses for the top 5 comments. So if you have any doubts, please share them in the comment box, as it will help you win. It could help you win the courses. Alright. So for now, we're taking questions that we have or that we got during the webinar session, and we'll be taking up the new questions that you're posting as and when it comes by. So to begin with, Roshni, can you give us a brief idea of what you've done in the webinar?
So in the webinar, I did 4 parts. Like firstly, I plotted the maps using MapShow. Then I created rotating globes. And thirdly, I created an interactive globe where when you click on a place, you'll get the latitude, longitude, location, and the place name. And finally, as an application, I did COVID-19 cases plotting in a world map.
So are there any add-ons or other toolbox that is required for this toolbox?
So in the webinar, like whatever I've done for that, you'll be requiring the image processing toolbox along with the mapping toolbox. In case, in some other applications, you might also require the aerospace toolbox. But as for the webinar contents, the image processing and mapping toolbox are sufficient.
We got a question from live. Satish Kumar is asking, can you explain geoshow command?
Geoshow command is actually for plotting the globe. It has a few attributes with it. Like firstly, geoshow is for plotting the globe. I can share my screen and show the attributes required. So we had used that in the rotating globe and also in the interactive globe. So when you see here we have used the geoshow command. And when we are using this command, we're using topo. So topology means the surface of the earth. So when we are showing that in the earth. And display type, it has a few attributes for it. So display type, we are using the texture map. That means it will load the texture of the earth. So this is the geoshow command. And we're using it again here. Here we are loading the latitudes and longitudes of the coastlines. So firstly, using geoshow command, we plotted the topology. Now we are plotting the coastlines. And we are giving a color for it. We have used a blue color. So these are the RGB values for that. And the line width 1.5. So these are like the attributes which are there for the geoshow command.
So that topo that you've mentioned above, is that like a variable in which you have some data, or is it like a value for geoshow? Okay, you loaded it here, no?
Yeah, that is like inbuilt MATLAB name for topology.
Okay. Okay. So topo legend is also something that you've loaded in this variable here.
Yeah, correct. That is also like an inbuilt MATLAB command.
Okay.
MATLAB name for topology.
Okay. So earlier you had mentioned that there is a need for the aerospace toolbox, right?
Yeah.
When will we use the aerospace toolbox?
So in case you need some details which are not there in the mapping toolbox, like in case of magnetic fields around the earth and all, those details are not there in the mapping toolbox. So for those kind of details, you need to have the aerospace toolbox. And basically the mapping toolbox itself is more beneficial when you combine it with other toolboxes. If
Okay.
used separately, it is only for visualization purposes.
Okay.
So my next question is, apart from plotting 2D and 3D mapping, are there any other functions in this toolbox?
Yes, so 2D and 3D mapping is just a part of the mapping toolbox. Apart from that, there is a part called data analysis. In that, you can analyze the data of the Earth, the surface and all. You can monitor the surface and analyze the surface heights and all. So there are many other applications like that.
Okay.
So there is a question from the YouTube live from Nikita. She's asking, I came across a command called QUIBERM
Okay.
in the mapping toolbox. What is that command?
Uh, Quiver is actually a type of map. In case you're plotting the velocity of a particular like wind and all, in that case you can use Quiver. Quiver is actually a mapping with in geobubble we used a point, a dot to explain the COVID-19 cases. In the case of Quiver plot, we'll be using arrow marks. So they are like vectors. It'll have two dimensions, x and y.
Okay,
And the command for that is Quiver m.
okay. So what exactly is a geobubble?
GeoBubble is actually a dot, like a bubble kind of thing, where it represent a particular country or a particular place and a data for that country. It will also be increasing in size according to the data. Like in COVID-19 cases, if the number of cases are high, then the bubble size will be larger.
Okay. It's okay. It depends on the data that we're considering. Suppose we are taking with respect to area, then probably based on that the bubble size will become bigger, right?
Yeah, correct.
Okay.
Um, so in your webinar, you had used the built-in data for the city of Concord. Are there any other built-in data for a particular location?
Yeah, actually, for one city, if you take Concord, there are subtypes like subdatas in that. There's a one package of data which will have roads, the place of the in the name place, the names of the places and all together in one file. Like that, there are many inbuilt datas in MATLAB. Mostly they are like cities of USA and all. For India, it is not available. You need to download it from some government website and import it into MATLAB. And there are datas like international boundary of that place, the coastlines, the roads, the streets of the city. So these datas are available.
Okay, what about if we want to plot for some other cities?
Then you need to download that from the government website and import it into MATLAB. And before using, it has to be in the shapefile format. That is a standard format for these kind of files.
Okay, then what is a shapefile?
Shapefile is actually a format of geographical location files. So the data in that will be in the form of matrix only, but then they will have some significance in the map. Like they are geographical datas.
Okay. Um,
So here we have another question from the YouTube live. It's from Garvit. He found your application of COVID-19 data on map very interesting. So he wants to know, is it any MATLAB version dependent
No,
to be able to run this? Sorry.
no, it is not dependent on the MATLAB. Actually, the version I had used is 2020. The geobubble command, as far as my knowledge, the geobubble is the command is present in like previous versions also. And the other
Okay.
commands that I had used were basic MATLAB commands only. So it is
Okay.
not dependent on the version.
Okay. Garvit, I hope your doubt is solved. Yeah.
okay. We got another question from the webinar premier. So when you displayed the globes, was it set constant or can we vary it? It is from Nikita.
Okay, the speed can actually be varied by changing few portions of the code, but while it is running, you can't change it. You can change it before running it, like in the code. You need
Okay.
to change the spin m function. I can show the portion where you have to change for that.
Yes.
So this is the rotating globe part. Here, I can just run it and show the current speed right now. Here we have used the spin function, and if you, it is actually an inbuilt MATLAB file. You are not creating the spin function. So if you want to edit that, you need to go to the command window and type doc of spin. So it will open this help file, and here you can see view code for spin. When you click that, you will get the code which is the inbuilt code for spin. Here actually by default it is there from 360 to minus 360-degree rotation, and minus 5 signifies that it is rotating in 5-degree steps. So it is very slow. In case you wanted to increase the speed, you can maybe set it to 10. So this is how you'll be able to change the speed of the spinning.
Okay. So what is that negative sign means?
Yeah, so by default, the Earth naturally rotates from west to east direction. So if you want to say, do the same here, you can use negative so that it will spin from west to east.
Okay.
So there is another question from the live. Can we plot the geobubble in an interactive globe? What changes do we have to make in the code? This question is from Nikita.
Okay, so you can do that. For that, you need to change few commands. Firstly, in the geobubble plotting, I had two tables combined into one. You need to do the same thing before you're doing it in the interactive globe, because for the geobubble command, you need a table before you're plotting it. Only from the table you can plot it.
Okay.
I can show you where you need to
Yes.
make the changes. Like this is the interactive globe. Here we are using the geoshow command here. So instead of geoshow, we can use the geobubble command, like how we have used it here. Here we have used the geobubble off command. So the same command you can use it here. But for geobubble, you need a table. So you need to create that table first and then give it as input.
Okay. Okay. So Nikita, I hope your doubt is cleared. Yeah.
We got another comment from Inia.
Okay.
So can you explain the COVID-19 data.m file?
So that is like a file which I created for getting the input from a website, to extract data from a website, the COVID-19 cases data. So this is the function that I created. Here, finally, I'll be getting a table named table overall A. So for returning that, we are creating this function. Here, this is the link which has the data. So I'm reading that website, and then I'm getting the data and storing it in 4 different columns, like the country, the updated time, the confirmed cases, and death. So these 4 columns, I'm converting it into a table, and that table is the table overall A, and you're naming the like the headings of the columns, and that's it. This function will return that table. So this is the COVID-19 data.m function.
Okay.
So the next question that we have here is from Mayuri, and she's asking, can you explain the attributes of the geobubble command? I think we've already taken this, right?
uh, yeah uh, no, we told it for geo show command.
Okay, okay, sorry.
So for geobubble, there are few attributes like the table name, which I showed. You need to give the table name. Then you need to show the latitude and longitude. Like the table, which column represents latitude and longitude. You need to
Yes.
show, give the name of the column, and then which is varying. Like here, the COVID-19 cases is varying. So the bubble size should vary according to that. So you need to mention according to what the size should vary,
Okay,
and that's it. You can mention the title and all, title of the map and all.
okay.
So we got another question. It is from Gravit.
Okay.
So in your webinar, you mentioned shapefile and you used some example from US data. How did you created that shapefile and how can I make it for my city?
Okay. So first, this Concord City shapefile, I didn't create that. It was already inbuilt in MATLAB. But in case you want to create it for your city, you can. There are few government websites. You can go to Google and search shapefile for your city, that city name, and you will get you can visit a website. And in most of the websites, you can download it in shapefile format itself. The data of the roads and all, it will be available. But in case it is not in shapefile format, then you can import it in MATLAB and you need to export that. So like this is also a function of MATLAB. In case it is not in shapefile format, you can import in any format and export, like you can convert it to shapefile format using MATLAB. So that is
Okay.
also one of the functions.
Why we need to convert it definitely to shapefile?
Because a shapefile is like a standard format used for such things. Like when you read it, you can use shape read command. And not just in MATLAB, in many other application softwares also, where they use this mapping purposes, there also they'll require only in shapefile format. That is like a standard format followed. So so you can import and you can convert it to shapefile format.
Okay.
So in your webinar, you'd only taken a portion of the, like, how do you show like a portion of the body? You've taken the entire globe, right?
Yeah.
So suppose I just want to focus on Asia or India. How do I do that?
Okay. So you first need to go to the command window and you can type world map. So when you type that, you'll be getting like a list of all the places that are available for plotting separately. For example, I'm plotting Asia here. You'll get the latitude and longitude locations required for Asia. You won't be getting the inner part because this is just for the latitude and longitude ones. If you want the inner part, then you'll need to load the coastlines. Then you'll get the outlines of the international boundaries also.
So coastlines are like the boundaries.
Yeah, correct. Boundaries of the continents or countries.
Okay. So my next question is, what do you mean by raster data?
So raster data is actually the data which is present in the shapefile. That is, it is a matrix of data, but each element in that will have some importance in a map. Like it will have some significance in the map. Like if it is a raster data of a particular country, then each element of that matrix, the each column and row element, it will have some significance. It might be one pixel of that, like of that city. So raster data is that.
Okay. Then where did you use this data exactly in your webinar?
In my webinar, the Concord city data was raster data.
Okay. Then all shape files can be called as raster data.
Yeah, the data of the places which is there is the raster data.
Okay.
So in the interactive globe, even if we did not click on a dot, it still displayed a name of a place. How does that happen?
Actually, there is a portion of the code where when you click a particular place on the interactive globe, the latitude and longitude location will be given as input to the code. Then you need to find the distance of that input to every other point, like every other dot. So using the basic math formula for distance between 2 points, you can find the distance. So whichever has a minimum distance means that that point is closest to the point where you've clicked. So it will display the closest points latitude and longitude range.
Okay. So my next question is, how exactly like or where exactly this toolbox is used in real life?
Roshni?
Yeah, sorry, Manoj, I couldn't hear you.
Okay. So what are the real life applications of this toolbox?
Yeah, so few applications are monitoring the environment. So when you monitor the environment, you can know the surface ups and downs and all. You can calculate the height of the mountain. You can compare the peaks in a particular area. And since you can monitor the environment, it is also used in defense purposes. Like you can monitor the surface of opponent country or some other countries. You can monitor the area And also you can analyze the data. You have data of places, then you can analyze like which is the lowest point in a particular area, which is the highest point. You can analyze those data and compare them.
Okay.
So there is a question that we got from the webinar. What is topology? Iny had asked this question.
Okay, so topology is like the ups and downs in a particular area. That is like the surface of the earth. The surface of the earth is topology. So when you're loading topology, it means that you're loading the curves, that is the ups and downs of the earth. So that is topology.
So my next question is, what do you mean by projections?
Yes, so projection is the angle at which, like, how do you want to view the Earth? You want to view it in a 2D surface, or you want to view it in a spherical shape, or from which angle do you want to see it? From above the North Pole, or in like you want to focus on all the continents or just one half? So all these things are projections. There are
Okay.
around like 60 types of projections available in MATLAB. Like all of them, they have minor difference between each one of them. So whichever is suitable for your application, you can use that. Like in the in, interactive globe, I use the semester projection because I thought that will be symmetrical from the equator, and it will have equal view of all the continents. So I thought that will be suitable for the application.
How can I change for if I want some other projection? Then how can I change it?
Okay, so there is a line in the code which you need to change if you want other projections.
Okay.
So here you can see I have used axis M sinusoid. Initially it was semester. That time we got a flat globe in the webinar. But in case you want other things like, for example, sinusoid is another type of projection. So here I just need to change the name here. Instead of here it was Bryce, instead of that I've changed to sinusoid. And this text is just the display in the like display when you're getting the output. So this is just a text. You can change that also. And in case like you know a projection type, but you don't know what is a keyword for that in MATLAB, at that time you need to type get m of map projection. So it will give you a list of all the projections available in MATLAB and along with the keyword. So here for Bryce semester, the keyword is Bryce. So like that, whichever you want, you can see the keyword and then type it near the axis M. Then you'll be getting the that type of projection. For sinusoid, you can see that it will be completely different from Bryce semester. You can see that it
Yes.
is very concentrated near the North Pole and South Pole, very expanded near the equator. So this is one type of projection.
Okay.
So the next question we have from the YouTube live is from Mayuri, and she's asking, I came across a command called the quiver M in the mapping toolbox. What is that command? I think we've taken this.
Yeah, we have discussed this one.
Yes. So Mayuri, if you still want us to discuss some part of it, then mention in the chat box about what specifically do you want to understand from that. Okay, so here I want to know how to plot a magnetic equator in the
Okay.
world map.
Okay. So for this, as I told, we'll be using the aerospace toolbox along with the mapping toolbox because
Okay.
it requires details of the magnetic fields and all. So this is like there's a very small code required for this. Firstly, the latest version of the magnetic field data available is 2015. So 2015 version, I'm just mentioning it here. And you need to load two files. Firstly, this is WMM results file that has the magnetic field data. And then you're loading that file. Secondly, it is a plot file. Plot file will be using to plot the magnetic field. So that is that file. And in between, you're just loading the land areas. That is for the earth. You're just loading the land areas. And then you have this command of ast plot WM curves. Magnetic fields are usually plotted as contours, so you're calling it and 3. Actually, the plot file here has 7 plots in it, 7 different plots. What we will be needing is a magnetic equator, which will be the third plot. Here, I plotted it and I'm giving the geographic latitude and longitude. So in the inbuilt file, the geographic latitude and longitude is given from minus 180 to 180. But what we actually want is the equator, that is 0 degree. In that case, you can go to the inbuilt file and change it to 0 and 0, so that you'll get only for the equator. But now we'll be getting like for the entire Earth, magnetic field entire, like for the entire Earth. So here, the green color portion is the zero latitude portion, and this is the magnetic equator that we want. And the other lines are magnetic fields at other latitude and longitude locations.
Okay. So if I want the equator, I just change the geolat and geolong that is mentioned in your code to the 0,
Yeah,
0.
yeah, 0, 0. You need to go to this AST plot WM quarters, like how we did for the spin function.
Yes.
You need to go and you need to change it there.
Okay. So now here I want to know that where have you used the aerospace toolbox?
So the data for the magnetic field is in the aerospace toolbox.
Okay.
Like
Okay.
these files are there in the aerospace toolbox, so you need it for them.
Okay. So this is already present in MATLAB. The data is already inbuilt in MATLAB.
Yeah, this is saved yeah, it is an inbuilt MATLAB.
Okay. Yeah. So Roshni, like this thing has, like you mentioned, 7 plots.
Yeah,
Roshni.
yeah, yeah, I can hear you.
Okay. So you mentioned that plot file has 7 different plot possibilities. So in general, how many does the mapping toolbox have?
Yeah, so there are many other types of plot also. Like I'll tell you the main types of plots which are present. Basically, there are mainly 3 types of plots. Another is a contour plot. Can you hear me?
Uh, yes.
Yeah. So 3 main types of plots: stem, contour, and scatter plot. So these are the main things. And as one of the comments were asked, like quiver, quiver is also one of the types of plot, like for
Okay.
plotting the maps. And I can show you what exactly these scatter maps and are.
Hmm.
So this is a scatter map. Scatter map is similar to the COVID-19 data which I plotted.
Hmm.
So you will
Okay.
have just the data scattered around, giving information about a particular place. This is a scatter map, and this is a stem. Stem plot will actually have like 2D representation of the data. Like the height will vary according to the data. So this is a stem plot. And contour plot. Contour plot is what we saw for this magnetic equator. Like the height difference will be shown in 2D level. Like as it goes higher, it will be
Hmm.
shown with smaller circles. So these are called contour plots. So these are the different types of plots available.
So you have taught the old map, right, in your webinar. So how can you differentiate the terrains and mountains or valleys or rivers and land area? Like, how can we differentiate it?
Actually, there are 2 types in which we can differentiate. One is the colors. So, color you can differentiate the rivers and land area, like blue color, green color. These data are actually automatically downloaded. When you download the topology itself, this color difference will come into the globe, and also you can the height and all will be differentiated again with color and also slight elevation. Like color means as the mountain is higher, it will be shown in brown color. So lower portions will be shown in yellow color. So this is how it is represented in color differentiation. Otherwise, you can see slight elevation on the surface. Like for the rotating globe one, we were able to see near the Himalayas, there was a slight outward projection. So it was, there were ups and downs also. So this is also used to represent the heights and all.
So Roshni, can you actually like measure the height and all with this uh, toolbox, or
Uh,
will we only be able to visualize the height?
Actually, if the data is available, then you can visualize it. In case the data is not available, and if you want to measure it, but then you need to have some other data for that, like the angle of elevation and the distance from the mountain. So if you have those kind of data, you can measure the height of the mountain. If it is not available, then if it is inbuilt available, the height of the mountain, then you can visualize it, like compare which is the highest peak in the region. So you can do that.
Okay, so that in that case, it is just basic trigonometry that will be applying to measure the height, right?
Yeah, it will be basic trigonometry. Just the data and visualizing part will be using the mapping toolbox.
Okay, okay. Manoj, you're mute.
Sorry. So could you tell us more about file importing and exporting utility in this toolbox?
So file importing and exporting, as I told, some applications, there are few applications like which require data. There, they'll specify like you can import only in shapefile format. But in MATLAB, that's not a condition like that. You can import in any format which is available. And while you are exporting it, you can export it in shapefile format. So that is one available feature of MATLAB. So in case you want some data, then you can import it and export it in required format. Like there are two types of data. One is the data or raster data, which is in shapefile format. Other is the data of the images that will be in geotiff format. These are the two standard formats, and you can export them in standard formats using mapping toolbox.
So what are thematic maps?
So thematic maps are the ones which convey a particular data about a place. Like it has some attribute which is to be conveyed. Example, you want to show the population of the countries, then it is a thematic map. Like you're conveying a particular data which is population. The COVID-19 cases, that is also a thematic example of a thematic map. So the types of thematic maps only were the scatter map, the contour map, the stem map and all.
Okay.
Before plotting or the map, can we process and analyze the data?
Yeah, like in case sometimes you need to process the data before plotting them, and in some other case, like you need to analyze them also. Like for example, you are drawing a straight line on a globe, and you want to get the height of the areas under that line. So in that cases, you will have to process them, and in some cases, you will be transferring large satellite data to Earth. In that cases, the data is very large, so it may take large amount of time and all to transfer. You can reduce the resolution of that image before transferring. So you need to process them, and after receiving, you can again increase. So low resolution images will take less time to transfer. So these kind of data processing can be done before you are performing mapping toolbox.
Okay. We are converting or we are decreasing the quality, right? So all these will be done by using image processing only, right? Image
Yeah,
processing
correct.
toolbox.
So this is where we'll be requiring the image processing toolbox along with the mapping toolbox.
So if I want to visualize the globe with respect to population, like
Okay.
population of all countries in the world,
Okay.
so what will be the steps required for processing or analyzing the data?
So first, you'll require the data of population from some source. So it will be in a table where you will have the country name and the number of people, that is the population. So mostly you won't be getting like latitude, longitude, and population data directly. You'll just get the country name and population. In MATLAB, we have latitude, longitude, and the country name. So you will have to combine these two uh, tables. So you need to combine latitude, longitude, and population. So this will become a table, and then you can easily use the geoshow command, or you can even use the geobubble command to plot it in a map.
So, what what is the difference between the geobubble or like a normal point in the map?
So geobubble, the only difference is that it varies in size. Like the data increases, the size increases. That is the only difference. And the normal types of points, you can plot it with the geoshow command. You just need to change point type to circle or whichever type you want. But geobubble is a separate command itself by its own. So this is like a difference.
So you are saying that we need to plot using geoshow command, right? So in geoshow command, before we are giving the attribute, do we need to convert the format into shape file?
Oh no, yeah, yeah, it has to be in shape file. But here you just have the latitude, longitude, and the
Population.
population. For the background, the areas and all, it has to be a shape file. I think the Earth shape file it is already inbuilt in MATLAB. So the details of the Earth it is already there in MATLAB.
Okay.
So Roshni, how do you convert vector data to raster data?
So raster data is just a matrix, normal matrix. So when you're converting, you can use the simple command that is vector to matrix. It is VEC to the number 2 and MTX.
Okay. And what exactly is georeferencing?
Like georeferencing is like a simple matrix. It has just the elements. But in the raster data, they are georeference. That means that each point will correspond to one point in that particular location. So
Okay,
that is georeferencing.
like suppose if there is a point A, then they will say that this is the latitude and longitude of A in this world map. So that
Yeah,
becomes
correct.
georeferencing.
Correct.
Okay.
So what are the web map servers?
Web map servers are used when the data is very large. Like you're not able to import them into MATLAB. That time you can use web map servers. They are uh, they are helpful when you can't import. So you can just access them whenever you want. So you do not download them and waste a lot of space and all. So just accessing them whenever you want is possible with web map servers.
Okay.
Roshni, you know how you mentioned that we can take the data uh, from actual websites also like Google and all.
Yeah,
So Google also provides this street view concept.
yeah.
So suppose say you have the data of every street in say one small place like Mumbai or Delhi being like a smaller place. Will you be able to visualize it doing in through this mapping toolbox?
Yeah, you can visualize it. If you have the data, then it is very much possible. Like in mapping toolbox, there is this function called dome and all. So you like a person is standing, you'll be able to view the dome around that person.
Okay,
So it is very much similar. Like it feels like you're standing on the street and you'll be able to view. Just that you
okay,
need to have the image data and all. So if it
okay,
is available, you can do it.
okay,
So in your webinar for the Concord city, you also use some images, right? Very broad and zoomed images.
Yeah.
Then how did you get those images and all?
So for Concord, actually, it is inbuilt only in MATLAB. But in case if you want from outside, then there are many sources. Like I told, images mostly people won't import it into MATLAB. They'll be using web servers only because they're
Okay.
very large. Web servers, example, I can tell you NASA web map servers. So that is one example. NASA observatory web map servers, they can provide you a lot of images like the street view and all can be provided by them. And also Google Earth can also be used for getting those images. And they'll be in geotiff format also.
Okay.
okay. So I guess I'm done with. Are you done with your questions, Manoj?
Yes.
Okay. So we'll wait for a couple of more minutes before we wrap up today's session. In the meanwhile, I'll guide you through the uh, certification procedure. So this is a yes. So this is the certification web page. There are 25 MCQ questions. but you must score about 60% or more to be eligible for the certification. Alright, you click on the start command. So here, which of the following command? So here, as you can see, these are MCQ based questions, and this here is the bar showing how many questions that you've completed. So now I'm just clicking on random answers. It shows whether your answer is right or wrong, and then you have to click here to move on to the next question. Alright. Now, one important thing here is that, as I mentioned earlier, we are giving away special benefits for the top 5 comments. Now, if we'll be discussing on the names soon. So, if you win this, if your name is being taken, then it's necessary that you attempt this certification within the next 24 hours and send us a screenshot of that on our WhatsApp number. We'll contact you within the next 48 hours, but it's necessary that you complete this because that is how we'll be able to interact or communicate with you. And secondly, in a lot of cases, what happens is is the name with which you're commenting on our live is different from the name actually with which you'll be attempting the quiz. So it's necessary that you mention that name, so that it's easier for us to connect with you. All right. Now the next thing, the premium courses that we were talking about. The premium courses include neural network, numerical methods, digital signal processing, and stock market application. All of this detail is directly available on our website, and you can easily go through this um, in our website. All right. So I guess we don't have any other questions. So before we end this session, I'd also like to mention next week's webinar, which is on image processing using fuzzy logic in MATLAB. You'll learn to implement fuzzy logic for image processing techniques like edge detection, noise reduction, and image segmentation. I personally find this extremely interesting, and I hope you'll tune in for next week's webinar as well. Till then, bye bye.
Vishaka?
Yeah, Roshni,
Yeah.
please take
Oh,
Okay.
5 best comments.
oh, sorry.
So I think Garvit, then Inia, Nikita, Satish Kumar, then Revenge Gaming. I have 5 done, right?
Yeah.
Yes, yes. So, sorry. Yeah, just those whose name we've taken, please mention your actual name in the chat box and also attempt the certification quiz. All right.
Okay.
So yeah. Bye bye.